A black hole is not a hole in the way we think of a tunnel in the ground, nor is it some kind of solid object you could touch. Instead, it is a region of space where gravity has become so strong, so impossibly powerful, that nothing can escape from it, not even light itself, which is the fastest traveler in the universe. The idea alone feels like something born from a dream, or perhaps a quiet nightmare, yet it is a real phenomenon described by physics. Imagine space itself bending inward, a pit so steep that once you tumble over its edge, you can never climb back out again. The beauty of this definition lies in its simplicity. A black hole is just a place where gravity has gone beyond every ordinary limit. Planets and stars all hold us with their pull, but if you try hard enough, you can escape their grasp, like a rocket leaving Earth. With a black hole, there is no amount of speed, no possible escape velocity, that could free you once you step past its invisible border. This border is called the event horizon, and it marks the line between the universe we can see and the world forever hidden inside. To soften the thought, think of it like an invisible curtain hanging in space. From far away, everything feels normal. The stars still shine, light still travels, and even if you orbited close, you might find yourself lulled by the familiar rhythm of space. But closer still, gravity deepens. The pull grows heavier, like a gentle hand that slowly turns into an unbreakable grip. Crossing the horizon, you are drawn inward, never to return. This is the quiet, solemn rule of a black hole. At its heart, a black hole begins as a star. A massive star, one far larger than our sun, spends millions of years burning fuel in its core, glowing and shining across the galaxy. Eventually, the fuel runs out. Without that burning to keep the star puffed up against gravity's inward pull, the star collapses under its own immense weight. For some stars, this collapse stops at a dense remnant called a neutron star. But for the largest, the collapse continues endlessly, creating the infinite pit of a black hole. The word hole is only a metaphor, and yet it fits so well. Imagine the fabric of the universe stretched like a soft sheet. Planets and stars press into the sheet, creating dips and curves. A black hole is the deepest dip of all, so steep that nothing at all can roll back out. It is the sharpest fold of reality, a place where time and space themselves bend into something strange. It is not an object so much as it is a region of altered spacetime. When scientists first dreamed of black holes, the idea seemed almost too strange to accept. Could there really exist places where light, the most untouchable and swift thing we know, could be trapped forever? For centuries, the notion floated quietly, dismissed by many as imagination. But slowly, evidence built up, from equations in Einstein's theory of general relativity, to the strange behavior of stars orbiting invisible companions, and finally to pictures of dark silhouettes against glowing gas. What was once theory became reality. The definition of a black hole carries a quiet weight, because it is more than a description of physics. It whispers something about limits, about regions of the cosmos where our ability to see, to know, and to measure comes to an end. Past the event horizon, no signal returns, no light escapes, no whisper comes back. It is the ultimate silence of nature, a veil no observation can lift. That silence is both frightening and profoundly beautiful. If you close your eyes and imagine one, do not see it as a hole swallowing everything in sight with reckless hunger. Instead, think of it as a dark star, quiet and patient, sitting in space. Its gravity is unmatched, but from a safe distance, it is no more dangerous than any other massive star or planet. You could circle around it, feel its pull, and yet continue safely, much like the Earth circles the Sun. Only those who come too close to the horizon are lost forever. A black hole's definition also rests on its geometry. The event horizon is spherical, smooth, and simple, like the surface of an invisible globe. No cracks, no openings, just a perfect boundary. To an outside observer, what lies beyond that surface is hidden entirely. It does not matter whether a spaceship, a star, or a cloud of gas crosses inside, the horizon makes no exceptions. Beyond it, the rules of physics as we know them twist into puzzles we cannot yet solve. At the center of this region, or at least in our current understanding, lies what is called a singularity. The singularity is a point where matter has been crushed into infinite density, where the laws of physics seem to break down. This is the most unsettling part of the definition, because it leaves us with unanswered questions. Our best theories cannot fully describe what happens there. The singularity is a reminder that black holes are both defined and undefined, clear in their outline yet mysterious in their core. Another way to define them is through their effect. You may never see the black hole itself, but you can see its influence. Gas swirling around it heats up and glows brilliantly before crossing the horizon. Stars orbiting nearby follow strange, tight paths that reveal the presence of something massive and unseen. Entire galaxies can be shaped by the giants that sit in their centers. So, while the black hole itself remains invisible, its fingerprint is written across the universe. This makes the definition both scientific and poetic. A black hole is absence made powerful, darkness made real. It is the point where existence folds in on itself and hides away. And yet, from that absence, light is born in the glowing disks of matter that fall toward it, in the great jets of particles hurled into space at near light speed. Out of the darkest thing in the cosmos comes some of its brightest displays. If you speak of black holes softly, you begin to hear their balance. They are not monsters in the sky, endlessly devouring. They are natural endpoints of stars, part of the great cycle of creation and destruction that shapes the universe. Just as clouds form and rain falls, stars live and die, leaving behind these strange remnants. Their definition is woven into the story of cosmic change, where endings make way for new beginnings. It is important to remember that black holes, despite their frightening reputation, are not traps scattered randomly through space. They are rare, far away, and distant. The nearest known black holes are many light years from Earth. Our Sun, being too small, will never become one. So in this definition, we can also place comfort. They exist, but they do not lurk around us like unseen predators. They are distant, calm, and majestic, part of the grand scenery of the cosmos. Defining a black hole gently also means emphasizing its elegance. For something that sounds so terrifying, its nature is remarkably simple. A black hole can be fully described by just a few properties: its mass, its spin, and its charge. That's all. Unlike stars or planets with complex surfaces, atmospheres, or weather, black holes strip existence down to a pure simplicity. They are cosmic minimalism at its most extreme. To imagine them, one might picture a sphere of darkness, a void surrounded by a glowing halo of light and matter. But the blackness itself is not a surface you could touch, it is only the absence of escape. If you floated near it with a flashlight, your light would arc and curve, some beams circling endlessly before falling in. To an outside observer, you might seem frozen in place, never fully crossing the horizon. In this way, black holes even play tricks with time. The definition, then, is as much about perception as reality. To those outside, the horizon is a boundary you never appear to pass. To the one falling in, it is just another step in an unstoppable journey. Black holes are defined both by what they are and how they are experienced. They are regions of space where perspectives diverge, where what you see depends on where you stand. Even the name black hole carries its own poetry. It was coined not long ago, in the 1960s, as a way to capture this unseen darkness in a simple phrase. Before that, scientists called them frozen stars or collapsed objects. The phrase black hole has a finality to it, a softness and a mystery, the same way a night sky whispers infinite secrets. Its definition is contained in its very name: black for the absence of light, hole for the escape that cannot be found. And so, when you drift into sleep, holding on to this gentle definition, think of a black hole not as a nightmare but as a quiet truth of the universe. They are not lurking monsters but natural phenomena, inevitable outcomes of stars too massive to hold themselves up. They are silent keepers of secrets, guardians of regions we cannot reach. Their presence makes the cosmos deeper, stranger, and more wondrous. The essence of the definition is simple: a black hole is where gravity has triumphed over all else, folding space and time into something new. But around that simple truth swirl mysteries, questions, and awe. To define them is only to begin to touch the surface of what they are. The rest lies hidden, waiting, in the quiet heart of darkness where even light cannot go. And in that thought, there is peace. The universe contains not only the bright stars we can see but also the shadows we cannot. The black hole is that shadow, carved into the fabric of space. It teaches us that not everything is visible, not everything is knowable, and that mystery has its own beauty. This is the gentle definition, carried like a lullaby, letting the mind drift between wonder and rest. A black hole does not announce itself with a dramatic roar or a blazing light. Its most haunting quality is its quietness. Unlike a star that shines across the darkness or a planet that reflects the glow of its sun, a black hole gives off no light of its own. It blends into the fabric of space, hidden, unseen, as though it were not there at all. Yet its presence is undeniably real, marked by the way it bends light around it, the way it tugs at nearby stars, and the way it sculpts the motion of galaxies. Its invisibility is not emptiness. It is an unseen gravity, silent but certain. The invisibility of a black hole is what makes it so strange. Our eyes are trained to seek light, to follow brightness, to trust what can be seen. A black hole denies that instinct, hiding completely from view. Even powerful telescopes cannot simply look at a black hole. Instead, they must search for what surrounds it, the glowing matter being pulled in, the stars dancing around something that should not be empty. The quiet presence is discovered not through direct vision, but through its unmistakable effects, like hearing footsteps in a dark room. Imagine standing in a meadow on a moonless night. The air is still, the stars faint above, and suddenly you sense a shape near you, invisible yet certain. That is how a black hole exists in the cosmic meadow, quiet, unlit, a patch of reality defined not by what it shows but by what it hides. And yet, just as you cannot see the wind but can feel its push, you cannot see the black hole but can feel its pull. Its gravity is its whisper, a reminder that unseen things may hold the greatest strength. This quietness should not be mistaken for weakness. Though invisible, a black hole is one of the most powerful presences in the cosmos. Stars near it spin with dizzying speed, light bends like water around a stone, and entire systems rearrange themselves under its pull. Its strength does not require sound or sight to be known. Instead, its reality emerges in silence, as though the universe itself bows in acknowledgement. In its quietness lies its dominion, subtle yet absolute. Astronomers have learned to treat invisibility as a clue. When a star seems to orbit nothing, when gas clouds move with no visible master, when light curves strangely through space, they suspect the hidden hand of a black hole. Its invisibility is a puzzle piece, an absence that shapes everything around it. We do not see the black hole itself, we see the choreography of its companions, all moving in answer to an unseen partner. Quiet though it is, its dance is unmistakable. Even when a black hole feeds, it does not reveal itself directly. Instead, the material around it, heated and stretched, glows in defiance before surrendering. We see disks of brilliant light, jets of matter streaming out, storms of energy flaring across the cosmos. But at the center of all that brightness, there is still only silence, only the dark mouth that swallows it all. The contrast between the glowing chaos and the invisible core deepens the mystery, reminding us that what we truly seek remains hidden. The quiet presence of a black hole speaks to something deeper in the human spirit. We are used to measuring reality by what we can touch, see, and hear. Yet here is something vast, undeniable, and unseeable. It humbles our senses, forcing us to accept that the universe holds truths that exist beyond human perception. It is a whisper of humility written in the stars, a lesson that not everything real needs to shine to be known. Invisibility also gives black holes their haunting reputation. Something unseen, pulling with irresistible force, is an idea that stirs unease. It echoes the fear of dark corners, of unseen depths beneath the sea, of voids where vision fails. Yet this fear is softened when you remember that the black hole is not malicious, it is simply a star's end, a natural consequence of physics. Its invisibility is not a trick, but a fact of nature, as quiet as the darkness of night. To detect such a presence, scientists must become patient listeners. They measure the wobbles of stars, the fading of light, the faint X-ray glimmers from gas heating up at the edge. Each clue builds a picture of the invisible. To the untrained eye, it may look like nothing. But to those who have studied, that nothingness is full of meaning, full of certainty. The quiet presence becomes as clear as any shining star, only revealed in subtler ways. One of the most astonishing ways black holes show themselves is through gravitational waves, the ripples in spacetime caused when two black holes collide. For billions of years, those ripples travel silently across the universe, passing through galaxies, stars, and planets without disturbance. Only the most delicate instruments on Earth can sense them, like listening to the faintest echo in the vastest hall. When we hear them, we know the invisible has stirred, its presence undeniable. It is easy to think that invisibility means emptiness, but a black hole is quite the opposite. It is matter compressed, space bent, time altered. It is a fullness so extreme that it becomes hidden. What we call invisible is actually an overflowing density, a concentration of being. It is as though reality itself has folded inward, so tightly, so completely, that no light can break free. This is not nothing, it is everything condensed into silence. The quiet presence of a black hole also alters time. To an observer far away, anything falling toward the event horizon appears to slow, never quite crossing, frozen at the edge. The falling object sees no such pause, it continues inward. This difference in experience is profound, a reminder that time itself bends under the weight of such gravity. Quietly, invisibly, the black hole changes not just space, but the very flow of existence. In some ways, a black hole is like a mirror that reflects nothing. You can look toward it, but no image returns. You can shine light into it, but the light never escapes. What remains is the awareness that something is there, unseen. This makes them both frustrating and fascinating, nature's ultimate concealment. They challenge us to trust in the invisible, to know that reality extends beyond what the eye delivers. Their invisibility also makes black holes surprisingly safe to observe from afar. Unlike a star that radiates searing light or deadly flares, a black hole emits nothing unless matter falls toward it. Sitting in the emptiness of space, it is a silent shadow, unnoticed unless disturbed. Its quiet presence makes it less like a predator and more like a sleeping giant, resting until the universe offers it something to consume. The presence of black holes at the centers of galaxies shows their quiet importance. Our own Milky Way spins around such a hidden giant, a black hole called Sagittarius A. For countless ages, it has sat there in silence, shaping the paths of stars, holding the galaxy together. We do not see it in the night sky, but its influence stretches across hundreds of thousands of light-years. Invisible, but real. There is a calmness in knowing that invisibility is not emptiness. Just as the roots of a tree lie hidden underground but nourish all above, a black hole's hidden presence holds entire systems together. It reminds us that some of the most vital forces in existence do not shine. They move quietly, unseen, yet their work is undeniable. This truth is echoed in the black hole's stillness. Even when scientists captured the first image of a black hole in 2019, what they showed was not the hole itself but its shadow, a dark silhouette against glowing matter. That shadow is the proof of invisibility, the shape carved by the unseen. The image was a triumph, not because it revealed the black hole's face, but because it confirmed that the invisible leaves traces we can follow. The quiet presence had finally left a mark for human eyes. To call it invisible is also to admit the limits of our tools. Perhaps one day, with new physics, new understanding, we may peer deeper into its secrets. But for now, it remains the silent figure in the background of the cosmos, shaping the stage without ever stepping into the spotlight. This makes it all the more mysterious, a presence that teaches patience and wonder. The quiet presence of black holes also mirrors the way silence shapes sound. Just as pauses give music its rhythm, the unseen shapes the universe's balance. Black holes are those silences, those dark pauses in the cosmic song. They are not interruptions but essential parts of the harmony, grounding the brilliance of stars in their quiet reality. For those who fear their invisibility, there is comfort in remembering distance. The nearest black holes lie far away, scattered across the galaxy. They are not hidden traps waiting to pull us in. They are rare, scattered, and distant, their quiet presence woven into the vastness of space. We live safely in their company, marveling from afar. And so, in the stillness of thought, the idea of a black hole becomes less frightening and more serene. It is invisible, yes, but so are countless things that guide life: the pull of Earth's gravity, the flow of time, the breath of air. A black hole's presence is simply another quiet truth of the cosmos, unseen but undeniable, gentle in its constancy, and endlessly real. The event horizon of a black hole is often described as a boundary, but it is not a boundary made of stone, metal, or walls. It is not a fence or a barrier you could ever touch. Instead, it is an invisible surface in space, a place where the rules change completely. On one side, the universe still belongs to us: we can see, communicate, send signals, and return. On the other side, there is no coming back, no matter how fast you move or how much you struggle. The event horizon is that one-way line, soft to the eyes, but absolute in its power. If you imagine the universe as an endless sea, the event horizon is like the quiet edge where the water suddenly tilts downward into a waterfall, flowing endlessly into darkness. From above, it might seem smooth and calm, nothing alarming to look at. But cross that line, and the current becomes irreversible. Just as water cannot flow back up once it plunges over a fall, nothing inside the event horizon can climb out again. It is not violent at the border itself, it is simply the point where escape is no longer possible. To an outside observer, the event horizon looks like a sphere, smooth and perfectly round, surrounding the black hole. It is not glowing, not shimmering, not marked by signs that say here is the edge. Instead, it is defined by the path of light itself. If light, the swiftest traveler, cannot escape past this surface, then nothing else can either. The event horizon is thus the shadow's edge, the border between the visible universe and the hidden interior. What makes it both fascinating and eerie is that nothing special happens when you cross it, at least from your perspective. There is no sudden jolt, no wall, no barrier that you could touch. If you were falling toward a black hole, you would simply drift past it, feeling gravity's pull steadily increasing. Yet in that quiet step, the universe behind you would be sealed off forever. It is a soft, one-way shore, invisible but final, like stepping over an unseen cliff. From a distance, though, the story looks very different. To someone watching you fall, you would appear to slow down as you approach the horizon. Your signals would become stretched, weaker, fading away until you seemed frozen at the very edge. In truth, you would have crossed long ago, but their eyes would never see it. To them, you remain hovering on the brink forever, trapped at the soft border of sight. The horizon, in this way, plays tricks with time itself. The softness of the horizon is an illusion of perception. Inside, gravity is merciless, pulling you inward without escape. Yet the crossing itself would feel calm, almost ordinary. It is like walking across a shoreline where the sand and sea look the same, but once you step forward, the current sweeps you away. The universe itself continues as though nothing has happened, and yet, the path behind you has vanished. Physicists often describe the event horizon as the point of no return. This phrase has a heaviness to it, but it is also gentle. The horizon does not strike you down, it does not shatter your ship or tear apart your body at the very moment of crossing. It simply marks the place where all journeys lead inward. It is an invisible gate, one way only, leading deeper into a gravity well with no exits. The size of the horizon depends on the mass of the black hole. For a small black hole formed from a single star, the horizon might stretch only a few kilometers across. For a giant black hole in the center of a galaxy, the horizon could span billions of kilometers. In either case, the rule remains the same: everything inside is sealed from the rest of the universe. The horizon is always soft to the eye, but absolute in law. In a poetic sense, the horizon is like the edge of a dream. On one side, there is light, time, and communication. On the other side, there is silence and secrecy. You cannot reach into it, you cannot receive anything from it, and so it remains a mystery, forever wrapped in shadow. The event horizon is not the end of the black hole, but it is the only face it shows us. It is the line between knowledge and unknowing. The horizon is also where physics stretches to its limits. Einstein's theory of relativity describes the warping of space and time around massive objects, and the horizon is where this warping reaches its ultimate form. Light curves around it, time slows near it, and cause and effect bend in unfamiliar ways. Beyond this point, our equations grow less certain, leaving us with questions. What lies past the horizon may never be fully known. And yet, this invisible surface is not just an abstract idea. Astronomers have captured images of glowing disks of matter circling black holes, where the horizon reveals itself as a dark center, a shadow no light escapes. In 2019, the first image of a black hole's horizon showed a glowing ring with darkness at its heart, the shadow of the event horizon itself. This confirmed that the soft shore, though unseen, leaves its imprint on the universe around it. The name event horizon carries its own meaning. Events, things that happen, signals, messages, flashes of light, cannot cross from inside to outside. They vanish beyond the horizon, never to be seen again. The surface is not physical, but it is the ultimate boundary for communication. Once something passes inward, its story in our universe is over. Its events belong now only to the black hole. There is a strange beauty in how the horizon hides without hiding. It is invisible, yet it casts the darkest shadow. It is intangible, yet it defines the very structure of the black hole. Like the surface of a calm pond concealing deep waters, it appears empty, but beneath it lies an unfathomable depth. The horizon teaches us that not all boundaries are walls, some are simply the edges where reality itself changes. Even though we cannot see past it, we can imagine the journeys that cross it. A star strays too close, stretching, tearing, and finally spilling its material across the horizon. From outside, we watch the star fade, never seeing its final fate. To us, it lingers at the edge forever. But to the star itself, the crossing is swift and irreversible. The shore is soft, but it divides forever. The horizon also reminds us of the limits of escape. On Earth, a rocket must reach a certain speed to break free of gravity. From the sun, that speed is higher. But from a black hole, the escape velocity at the horizon equals the speed of light itself. Since nothing can move faster, nothing can leave. The event horizon is not a wall, but a speed limit, an unreachable threshold written into the laws of physics. There is something gentle in thinking of it as a shore. Shores are places where worlds meet, land and sea, light and dark, the known and the unknown. The event horizon is the cosmic shore, the place where our universe touches the hidden realm of the black hole. It is a border, yes, but also a meeting point, a reminder that even in the silence of physics, there is poetry. This shore is not lonely, for it is often surrounded by radiant light. Matter circling a black hole glows brilliantly, swirling in disks that shine brighter than entire galaxies. Against this brilliance, the horizon remains calm, a dark silhouette framed by fire. Its stillness stands in contrast to the chaos around it, a quiet center to the storm. The shore does not move, does not change, it simply waits. For travelers in imagination, the horizon is both the end and the beginning. To cross it is to leave behind the universe we know, to enter a place where time and space fold strangely. But for those who remain outside, it is the end of the story, a silence that no signal breaks. This duality makes the horizon one of the most mysterious features in all of physics. Even as we dream about what lies beyond, we accept that the horizon protects its secrets. Nothing can pierce it, no telescope can see through it. This mystery is not a flaw, it is part of the nature of reality itself. The horizon guards the hidden interior, leaving us to wonder, to imagine, and to approach with reverence. Its quiet power is in what it refuses to show. The softness of the horizon also inspires, or because it is impartial. Stars, planets, gas clouds, even light itself, all are treated the same. No matter how massive, no matter how swift, once they cross, they are bound. The horizon does not discriminate, it does not negotiate. It is the purest expression of gravity's law, applied universally. For the galaxies that host them, the horizons of supermassive black holes shape everything. They may hide quietly, but their presence defines the motion of millions of stars. The horizon, though invisible, becomes the unseen anchor of entire cosmic systems. Its one-way silence is not just a curiosity, it is a structural truth of the universe. And in the end, the event horizon is a reminder of humility. It tells us there are edges we cannot cross, mysteries we cannot reclaim, places where our knowledge must pause. It is soft, yes, invisible, yes, but it is absolute. A one-way shore, eternal and quiet, marking the places where light itself bows and does not return. And in that thought, there is wonder, and a silence deep enough to carry us into dreams. When we speak of spaghettification, the word itself sounds almost playful, yet it describes one of the most unsettling experiences a body might endure near a black hole. The idea is simple: as you approach, gravity's pull is not the same across your body. The part closer to the black hole feels a stronger tug, while the part farther away feels slightly less. This difference stretches you out, slowly at first, but relentlessly, until you are drawn into a thin, elongated shape, like a strand of spaghetti falling into the dark. This stretching begins subtly, so quietly that at first you might not notice. Your feet, if they are pointed toward the black hole, would feel a stronger pull than your head. It is not a yank or a snap, it is a gradual tension, the kind that grows stronger with each passing moment. Muscles and bones would resist for a while, holding you together, but the difference in gravity, called tidal forces, would eventually outmatch the strength of matter itself. You would be stretched in one direction, squeezed in others, transformed by gravity's embrace. Spaghettification is not confined to people or small objects. Even stars, entire worlds, and great clouds of gas can experience this fate. When a star wanders too close to a black hole, it is pulled apart, stretched into glowing streams of plasma that spiral inward. From afar, it looks like a delicate ribbon unraveling, a luminous strand of starlight drawn across the darkness. The quiet horror lies in how graceful it seems, as though destruction could masquerade as art. The closer you fall, the faster the stretching becomes. It is not only the difference in pull from head to toe, but also the difference across your width, squeezing your sides inward as your length grows. This dual effect makes the transformation even more dramatic. Imagine dough being rolled out, stretched long and thin, while at the same time compressed into a narrow strand. The universe itself acts as the rolling pin, turning solid bodies into elongated ribbons of matter. The name may sound humorous, but the reality is sobering. It was coined to give shape to something otherwise difficult to imagine, to make the unimaginable just a bit more approachable. The universe often hides its harshest truths behind quiet names, and spaghettification is one of them. Underneath the light-hearted sound of the word lies the inescapable reminder of gravity's merciless nature. To an outside observer, spaghettification would unfold slowly, almost lazily. As you approach the horizon, your body would appear to stretch and fade, your signals lengthening into lower and lower frequencies until they vanish. You would seem to linger at the edge, half-formed, stretched across time. To you, however, the process would feel rapid and unstoppable. Time bends differently for each perspective, making spaghettification both a slow spectacle and a swift demise. Even though it sounds like something out of a tale, spaghettification is written into the mathematics of relativity. The stronger the gravitational gradient, the difference in pull across your body, the more intense the stretching. Near a small black hole, this gradient becomes deadly long before you reach the event horizon. You would be torn apart outside the boundary, unable to even glimpse its secrets. But near a supermassive black hole, the horizon lies so far out that you could cross it intact, only to face spaghettification much deeper inside. This difference reveals a strange truth: not all black holes feel the same to those who fall into them. A smaller black hole is like a sharp, sudden rip, tearing apart matter before it even reaches the horizon. A supermassive black hole, by contrast, allows a slower journey, a quieter fall past the horizon, before the stretching takes hold. In either case, the end is the same, but the path differs, some quick and brutal, some drawn out and almost gentle. The idea of being stretched into a thin filament is unsettling, but it also sparks a peculiar sense of awe. Imagine matter pulled so far apart that it becomes something new, no longer recognizable as the shape it once had. Stars shredded into ribbons, planets torn into streams, people or objects transformed into threads finer than imagination. Gravity reshapes existence itself, turning the familiar into something alien. Spaghettification also speaks of the universe's indifference. It does not matter what you are: rock, gas, star, or living being, the tidal forces act without preference. The stretching is impartial, following the same laws for everything. It reminds us that in the presence of such cosmic power, all are equal, all subject to the same fate. There is a strange kind of fairness in this indifference, though it is a fairness without mercy. From the perspective of science, the process is clean and precise. It is described in equations, predicted by models, and observed indirectly when stars are torn apart. But from the perspective of imagination, it feels haunting. The thought of matter being drawn into strands, like threads pulled from a fabric, suggests the unraveling of reality itself. It is both a destruction and a weaving, as if the black hole is unmaking and remaking the universe in silence. One can picture a cloud of gas meeting this fate, drawn into a long arc of light that swirls gracefully around the black hole before vanishing. Astronomers have seen these tidal disruption events, where a star's spaghettification lights up the darkness in one last blaze. For a brief time, the black hole's quiet presence is betrayed by the glowing trail of its meal, as though the act of stretching leaves behind a luminous signature. In a softer sense, spaghettification is a reminder of the fragility of structure. Everything we know is held together by forces, atomic bonds, molecular links, the cohesion of matter. Yet even these can be undone when faced with something greater. The pull of a black hole is so absolute that it ignores the boundaries of atoms and molecules, stretching them into new forms. What we call solid is only solid until gravity proves otherwise. Even light is not immune. Though it cannot be stretched in the same way as matter, its path bends and twists under gravity's pull. Streams of radiation curve, orbit, and finally fall inward. The spaghettification of light is more about its journey, its redshifting into longer and longer waves, its final fading into invisibility. Gravity stretches not only bodies but the very signals that reveal them. There is an odd comfort in knowing that spaghettification, for all its dread, is distant from us. The black holes nearest to Earth are many light-years away, their tidal forces far too weak to touch us. The stretching belongs to the realm of imagination, thought experiments, and distant observations. It is a truth of physics, yes, but one that remains safely out of reach. This distance allows us to marvel without fear. In stories, spaghettification often appears as a warning, a symbol of the limits of exploration. It says, "Here is the line where curiosity meets consequence, where wonder turns into silence." It is the dramatic reminder that black holes are not merely puzzles to be solved, but boundaries that challenge the very persistence of form. It is both a scientific truth and a mythic lesson. The stretching is not endless. Eventually, the strands of matter are consumed, pulled past the horizon, folded into the black hole's hidden depths. The ribbons, however long and luminous, do not remain. They are swallowed whole, leaving only a memory in the surrounding light. The process is temporary, a fleeting transformation on the path to disappearance. And yet, in those fleeting moments, spaghettification reveals the invisible power of the black hole. It shows us the tidal forces in their most dramatic form, tearing and reshaping matter. Without these effects, black holes might remain hidden forever, silent shadows in space. But through this stretching, they leave their signature, visible to those who watch carefully. Some have wondered what it might feel like in the final instant, when the stretching becomes too much. Would it be pain, or would it be too sudden to register? Would the distortion of time make it a drawn-out eternity or a blink of existence? These are questions with no answers, only speculations woven into the quiet mystery of what happens at the threshold of gravity's extremes. Spaghettification may sound grotesque, but it is also elegant. It is not a violent shattering but a gradual transformation, a pulling apart that seems almost graceful from a distance. Like a thread unraveling from a tapestry, the process is delicate, inevitable, and strangely beautiful. The universe, in its indifference, makes even destruction look serene. In some ways, spaghettification is a story about scale. It reminds us that the universe operates on levels far beyond the human. Forces that seem unimaginable to us are ordinary in the lives of stars and galaxies. Our bodies, fragile and small, would not survive such a pull, but stars themselves cannot either. The stretching is a cosmic equalizer, treating all forms of matter the same. This slow pull that stretches also whispers something about impermanence. Nothing, no matter how solid or mighty, is immune to change. Just as rivers carve stone over millennia, the pull of a black hole reshapes everything that comes too close. In the grand design of the cosmos, permanence is an illusion. Stretching, breaking, and remaking are simply part of the cycle. And so, spaghettification is not only an ending but a transformation. Matter stretched and consumed does not vanish from existence. It becomes part of the black hole, adding to its mass, contributing to its growth. In that way, the strands of matter continue, their essence absorbed into the dark heart of gravity. Even in destruction, the universe continues its quiet cycle of renewal. The word may sound light-hearted, but the reality is profound. Spaghettification is the final testament to gravity's rule, the point where resistance ends and surrender is complete. It is a slow pull, a quiet reshaping, a soft but absolute reminder that in the presence of a black hole, nothing escapes unchanged. Time itself, something we so often think of as steady and universal, begins to bend and soften when gravity grows strong. Near a black hole, clocks do not tick the same for everyone. For someone far away, time keeps its familiar rhythm, flowing like a calm river. But for one who drifts closer to the immense pull, the flow slows, thickens, becomes syrup-like, dragging out each second. This slowing of time is not a trick of perception, it is the very fabric of space-time stretched by gravity's weight. Imagine holding two clocks, one left safely far from the black hole, the other carried down toward its shadowed edge. At first, both tick together in harmony, like two voices reciting the same song. But as the second clock descends, its ticks grow lazy, lagging behind, while the distant clock carries on at its normal pace. To the falling observer, their own time feels unchanged, their heartbeat steady, their thoughts unbroken. Yet to the one watching from afar, that heartbeat slows, becoming a distant echo, fading into silence. This phenomenon, known as gravitational time dilation, is not confined only to black holes. Even here on Earth, clocks in orbit run slightly faster than those on the ground, because gravity is weaker higher up. Our satellites must account for this difference, or navigation systems would fail. Yet near a black hole, the effect grows unimaginably intense, until moments stretch into eternities, and the passage of time loses its shared meaning. The hush of time near a black hole is like a soft pause, a long breath held by the universe itself. For the traveler, nothing seems strange, they live each second as they always have. But when they look back, they would see the universe above them rushing forward, stars wheeling, ages passing, while they remain caught in a slower current. To look outward is to glimpse the future unfolding in fast forward, a dizzying reminder of how unevenly time can flow. For those watching the descent, the picture is reversed. They see the traveler slowing down, their movements stretched thin, their signals growing longer and weaker until they fade into silence. The traveler never quite crosses the horizon in the eyes of the distant observer, they seem to freeze just above it, suspended in the hush of stretched time. To the falling one, though, the journey continues, seamless and unbroken, into the depths. This strange dance of perspectives makes time feel fragile, as though its constancy is only an illusion of our safe distance. Near the black hole, it becomes clear that time is woven from the same cloth as space, and both bend under gravity's hand. To be near such a place is to feel the hush of time like a soft, unseen weight pressing gently upon every moment. It is a slowing that cannot be resisted, a quiet surrender of clocks to the pull of gravity. In this hush, a minute may stretch into hours, hours into days, and days into centuries for the outside world. A traveler circling near the event horizon might only experience a short span of living, while for the universe beyond, whole epochs might pass. Civilizations could rise and fall while the traveler takes only a handful of breaths. The hush of time creates a gulf wider than distance itself, a separation of when, not just where. The thought carries both dread and wonder. It is unsettling to think that time could slip away differently for two beings in sight of one another. Yet it is also enchanting, a reminder that time is not rigid but alive, responding to the gravities of the cosmos. It flows like a river with currents both swift and slow, carrying each traveler in its own rhythm. Near a black hole, that rhythm grows hushed, as though the ticking of existence itself bows before the dark. This slowing of time is not just a boundary for explorers, it is a source of fascination for physicists. It shows us that reality itself is pliable, that even something as absolute as time can bend under the laws of relativity. In this bending lies the key to understanding not only black holes but the entire structure of the universe. Each hush of time tells us that nothing is fixed, that even clocks obey the pull of stars and the darkness between them. Imagine standing on the edge of such a place, aware that your minutes are stretching against the hours of the universe beyond. The sky above would whirl at unnatural speed, the stars rushing in their lifetimes, galaxies twisting through ages, all while you feel only the gentle, steady beat of your own moments. To live in such a hush is to glimpse the impermanence of all else, the fleetingness of time as seen from another shore. And still, the hush is not violent. It does not tear or rip. It is soft, quiet, like a lull in music. Time slows like the dimming of a candle's flame, gentle but unstoppable. It carries a strange serenity, as if the universe itself leans in to whisper, "Here, even time must pause." That pause is what makes the horizon such a mystery, a place where every observer's story of time unravels into a different tale. From a distance, we imagine this hush as eerie, frightening in its silence. But for the traveler, there is no fear. They feel only the continuity of their steps, their thoughts, their heartbeat. It is the watchers who see the change, who witness the slowing, who wonder where the final moment goes when it no longer ticks in rhythm with their own. In that difference of perception lies the poetry of relativity, a story of how time itself bends into quiet. The hush also reveals why black holes are such effective vaults for secrets. Anything that falls near them seems to vanish slowly, its signals drawn out until they fade. The universe cannot watch the final plunge directly, for time near the horizon is slowed beyond its gaze. What happens within remains hidden, not just by the event horizon itself, but by the soft curtain of time's hush. There is a strange parallel here with sleep itself, where hours slip past unnoticed, and time feels altered. In dreams, moments expand and collapse, making minutes feel like days or days like mere blinks. In the hush of a black hole, something similar unfolds, but on a scale written not in the brain but in the very geometry of space-time. It is a dream woven into the laws of physics. The hush does not belong only to those who fall. Even light, the swiftest traveler in the universe, feels its passage. As light climbs out of a gravity well, its waves are stretched, its frequency lowered. The light grows redder and weaker, as though tired from climbing. This gravitational redshift is another form of the hush, a slowing not of clocks but of signals, a fading whisper as photons stretch their way free of the pull. And so, when we gaze at light from near a black hole, we are not only seeing matter caught in its orbit, we are seeing time itself slowed, colors drawn into longer notes, the melody of radiation pulled low by gravity's hand. The hush of time writes itself in red and shadow, marking the rhythm of existence around the abyss. One might wonder what it would mean for memory, for thought, for self, to live in such a hush. Would the traveler feel like they have escaped the world, stepping out of its rushing current into a slower stream? Or would the change be invisible, their own heartbeat anchoring them in what feels like normal flow? These questions linger because time is both universal and personal, both shared and subjective. For the cosmos, this slowing of clocks is more than a curiosity. It shapes how black holes grow, how they reveal themselves, and how information might move or fail to move across their boundaries. Time's hush is part of what makes black holes so mysterious, for it changes how we perceive everything near them. To study such a hush is to study the boundary between what we know and what we cannot reach. If one could hover safely near a black hole and look outward, the experience would be breathtaking. The rest of the universe would appear to race ahead, stars aging in a blur, galaxies turning with unusual speed, as though all of creation had been set to fast forward. And yet, within yourself, the hush would feel calm, unbroken, a private rhythm untouched by the rush outside. It is humbling to realize that the universe does not keep one single time for all. Instead, each place, each gravity well, writes its own pace into the fabric of space-time. We live in our own river of time here on Earth, but there are countless other rivers, flowing faster or slower, winding differently across the cosmos. The black hole's hush is simply one of the deepest bends in that endless current. This idea reshapes how we think of eternity. For a traveler near the horizon, eternity might last only moments of their own time, while the outside universe spins through countless years. For the universe watching, that traveler's moments may seem to stretch into forever, frozen in descent. Eternity itself becomes relative, redefined by where you stand in gravity's hush. The hush also serves as a reminder that endings are not always abrupt. Sometimes they arrive quietly, through a slowing, a pause, a fading into silence. The black hole does not consume swiftly in the eyes of those who watch, it hushes time until the final plunge is unseen, untouchable. This slowness is both haunting and comforting, a cosmic lullaby that hides the last step from view. And so, in the end, the hush of time is both mystery and gift. It reminds us that the universe is stranger than our simple measures allow, that even the ticking of clocks bends to the will of gravity. It whispers that time is not fixed, not absolute, but pliable, soft, and gentle under the pull of the cosmos. To listen to that hush is to hear the universe breathe in silence, slowing the moments until they fade into eternity. The singularity of a black hole is spoken of as the deepest, most secretive place in the universe, and yet it is not a place in the sense that we understand. It is not a room or a cavern or a core made of matter. It is instead the point where our maps, our equations, our understanding all simply fall silent. At the singularity, gravity pulls so tightly, space-time curves so sharply, that the known laws of physics can no longer guide us. It is the edge of knowledge, the blank space on the chart where even the boldest explorers must pause. When scientists describe it, they speak carefully, for the singularity is not something we can see or touch. It is hidden deep within the event horizon, beyond all communication. It is not a visible dot, not a glowing core. It is simply the word we give to the place where density becomes infinite, where matter is crushed beyond recognition, where time and space themselves fold into a single point. In this description lies awe, but also unease, for infinity is not something our universe wears easily. Imagine a mountain crushed down into a pebble, then a pebble crushed into a grain, and then that grain pressed further still. The singularity is like the end of that process, but beyond imagination, where every particle of a star, every ounce of matter that has fallen, is packed into a point of no size at all. Density becomes infinite, volume shrinks to nothing, and the ordinary structure of reality breaks down. It is not matter as we know it, it is a riddle, hidden behind the black hole's curtain. For the traveler who dares fall inward, the singularity is the final destination, though they will never send back word of what it holds. The descent feels ordinary at first, a steady pull, a slowing of time, the crossing of the event horizon. But as the plunge continues, gravity grows stronger and stronger until no structure, no body, no atom can remain intact. Spaghettification stretches, tears, and carries everything forward until, finally, all paths converge on the singularity itself. To speak of the singularity as a point may be misleading, for it is not a place that one could ever stand upon. It is better thought of as the end of space and time. The equations of general relativity tell us it must exist, that all paths curve toward it once inside the horizon. But at the same time, those equations fail to describe what truly happens there. This contradiction is why the singularity feels like both an answer and a question, a destination and a mystery all at once. Einstein's theory paints the path toward the singularity, but it also admits its own limits at that final step. Physics as we know it ends there. Beyond lies a silence, a gap waiting for a deeper theory, perhaps a unification of gravity and quantum mechanics. Until then, the singularity is less a physical place than a marker of our ignorance, a line drawn where human understanding can no longer reach. And yet, the idea of the singularity is more than mathematical despair. It is also a beacon, pointing us toward the mysteries we have yet to uncover. It reminds us that the universe is not finished giving up its secrets, that there are realms where our best ideas must grow further, must evolve. In its silence, the singularity invites curiosity, challenging us to imagine new physics, new ways of seeing reality where time and space dissolve. From a distance, the singularity remains hidden, shielded by the horizon. To us, it exists only as theory, never as sight. But its presence is felt in the black hole's power, in the way light bends around it, in the way stars vanish when they wander too close. The singularity is the unseen heart that drives the black hole's gravity. Though we may never witness it directly, its influence shapes galaxies, stars, and the very dance of the cosmos. Some imagine that singularities might not be simple points at all. Perhaps they are gates to other regions of spacetime, perhaps tunnels or bridges to distant universes. These ideas are speculative, fragile as dreams, but they arise because the singularity defies ordinary logic. If the known laws collapse, perhaps other structures, other possibilities, may take their place. What lies there may be stranger than we can yet name. And yet, we must also accept that the singularity may remain forever beyond us. It is hidden not just by distance, but by the very nature of black holes. No signal, no light, no information escapes the event horizon, and so the singularity is locked away, eternally unseen. It is a reminder that not all mysteries will yield, that some truths remain veiled, their silence part of the universe's design. The singularity is, in some ways, like the heart of a story we are not allowed to read. We can trace the chapters that lead toward it, the collapse of stars, the curving of space, the hush of time, the soft boundary of the horizon. But the final page is torn away, missing, forever out of reach. What lies there is known only to the black hole itself, never to the reader outside. If we think of the universe as a grand map, drawn with stars and galaxies, the singularity is where the map ends. It is the edge of the paper, the uncharted territory where the cartographer must stop and write, here lies the unknown. Beyond it, there are no coordinates, no directions, no familiar terrain. The singularity is the place where our navigation tools, our science, our equations, our words simply fall silent. And yet, even in this silence, there is meaning. The singularity tells us that our knowledge has limits, and that those limits themselves are valuable. To stand at the edge of understanding is to recognize the vastness of what lies beyond. The singularity humbles us, reminding us that we are children of the cosmos still learning to speak its language. Its mystery is a teacher, showing us how much more there is to know. For the black hole itself, the singularity is the anchor, the core that holds its immense power. All the matter, all the energy, all the collapse flows into that single point. Without it, the horizon would not exist, the gravity would not reach outward. The singularity may be unseen, but it is the reason the black hole commands the cosmos around it. It is absence and presence at once. Even as we ponder its mystery, we cannot escape its inevitability. Any star that collapses beyond a certain mass will end in a singularity. It is not rare, not exotic, black holes with singularities likely number in the trillions across the universe. Each one holds its own unseen point, its own place where time ends, where density grows infinite, where physics falters. The singularity is not a singular phenomenon, it is written everywhere into the fabric of cosmic evolution. Still, its strangeness makes it feel alien, almost impossible. To imagine infinite density in a point of zero volume is to leave the comfort of ordinary thought. We picture stars, planets, clouds of gas, but we cannot picture this. Our minds resist, for infinity is not a thing to be visualized, it is an idea, a whisper of mathematics where the physical slips away. There are those who hope that one day quantum gravity will tame the singularity. Perhaps particles and fields, governed by rules deeper than relativity, will reveal a structure where now we see none. Perhaps the singularity is not truly a point, but something hidden, layered, a knot in spacetime rather than its end. If so, then the maps will extend further, into lands we cannot yet describe. But until that discovery comes, the singularity remains a silence. It is easy to feel fear in the thought of it, the crushing density, the collapse of space and time. And yet there is also beauty in its mystery. The singularity is the universe telling us, softly, that it still holds secrets beyond our grasp. It is a reminder that wonder lives not only in what we know, but in what we cannot yet know. It is the deep night sky of knowledge itself, dotted with gaps where answers still wait. Even for the traveler, the singularity is unreachable as an experience. Long before reaching it, their body and atoms would be undone, stretched and dissolved. The path to the singularity is one that no being can survive. It exists, in truth, only as an idea for us, a destination that cannot be lived. In this way, it is not just hidden behind the horizon, but hidden behind the very limits of life. Yet, in the imagination, we can trace the journey inward, past the glowing disks, across the silent horizon, through the stretching of spaghettification, into the narrowing tunnel where all roads converge. And there, at the end, we arrive at a place we cannot describe, a place where language falls still. That stillness is the singularity itself, a point where our words, like light, cannot escape. It is not a place of endings only, but of beginnings too. From the collapse of stars, singularities are born. From the centers of galaxies, they shape the dance of billions of suns. In their silence, they guide the structure of the universe. And perhaps, in ways we do not yet understand, they may connect to other universes, other realities. They may be seeds, not just tombs. So, we linger at the edge of the idea, unable to pass, yet unwilling to turn away. The singularity remains one of the greatest mysteries of science, one of the deepest poems of the cosmos. Where our maps end, imagination begins, and in that beginning lies the promise of discovery. The singularity is where knowledge pauses and wonder grows. Even now, as we whisper its name, it feels more myth than fact, more question than answer. And yet, the mathematics insists, the observations demand, that it exists within the darkness of every black hole. It is real, even if unseen. It is waiting, even if unreachable. It is the quiet center of cosmic gravity, the point where all stories curve inward and dissolve. To think of the singularity is to stand at the edge of a cliff in the night, peering into mist, knowing something lies below but unable to see its shape. It is the hush of mystery itself, a promise that the universe is greater than our present understanding. It is the final step of the black hole's tale, but also the beginning of questions that will echo far into the future. And so the singularity, where our maps end, is not a failure of knowledge, but its frontier. It is the place where we admit we do not yet know, and in that admission lies strength. For it is in the unknown that science breathes, that curiosity stirs, that wonder awakens. The singularity is not only where space collapses, but where possibility expands. It is silence, yes, but it is also the echo of futures yet to come. Around a black hole, silence gives way to violence. While the heart of the black hole itself is hidden, the region just outside the event horizon is one of the brightest, loudest, and most energetic places in the universe. Matter falling toward the black hole does not always plunge straight in. Instead, it forms a swirling disk, circling like water around a drain, heating to extraordinary temperatures. This glowing disk, known as an accretion disk, shines so fiercely that it can outshine entire galaxies. The gas and dust that form this disk are torn from stars or pulled from clouds wandering too close. As these fragments spiral inward, friction and pressure squeeze them tighter, making them glow with brilliant light. From afar, it is as if a black hole wears a halo of fire, a paradox where the darkest object in the universe is surrounded by one of the brightest displays. The glowing disk is not calm, it is turbulent, alive with storms of magnetic fields and shockwaves. The violence does not stop with light. Black holes often produce jets, colossal streams of particles blasted into space at nearly the speed of light. These jets shoot from the poles of the black hole, extending for thousands or even millions of light-years. They are so powerful that they shape the galaxies around them, heating gas, sculpting clusters, and influencing star formation. The black hole itself is silent, but the neighborhood it creates roars across the cosmos. To picture the scale, imagine a single black hole launching a jet longer than the width of its host galaxy. Within those jets, particles race outward, colliding with interstellar gas, creating radio waves and X-rays that astronomers can detect from billions of light-years away. In their fury, these jets connect the unseen singularity to the visible universe, leaving behind fingerprints we can follow. The violence becomes a bridge between what we cannot see and what we can. The accretion disk itself is a place of extremes. Temperatures soar into the millions of degrees, hot enough to strip atoms of their electrons. Matter glows not in gentle visible light but in blinding X-rays, invisible to human eyes but caught by space telescopes. The closer the material falls, the hotter and faster it spins, until time itself seems to stretch in strange ways. This glowing whirlpool is the last cry of matter before it crosses the horizon. And yet, even in this fury, there is beauty. The swirling light forms rings, often warped by the immense gravity bending it into strange patterns. Photons curve, creating echoes and distortions, giving us a ghostly glimpse of the black hole's silhouette. In 2019, the Event Horizon Telescope revealed such a ring around a supermassive black hole, a glowing circle surrounding a dark center. It was humanity's first direct vision of the violent neighborhood around one. This neighborhood is violent not only in radiation and jets but also in how it tears apart what enters. A star straying too close might be shredded in a process called tidal disruption. Its gas streams into the disk, igniting a flare visible across galaxies. These outbursts are brief but spectacular, a reminder that black holes do not always feed quietly. Sometimes, their meals are cataclysmic feasts, leaving scars of light upon the sky. The violence is driven by hunger, by gravity's relentless appetite. The black hole itself does not spit matter back. Instead, the jets and light are born from the chaos outside the horizon. Magnetic fields twist and knot, flinging particles outward even as most matter falls in. The paradox is striking. In falling toward silence, matter screams its brightest, sending light and energy into space. For galaxies, these violent neighborhoods are not just curiosities. They help regulate cosmic growth. A feeding black hole's jets can heat the gas in its galaxy, preventing new stars from forming. In this way, black holes play the role of gardeners, pruning galaxies, shaping their fates. Without them, galaxies might look very different, their growth unchecked, their structures unfamiliar. The roar of the neighborhood also carries across time. Light and radiation from accretion disks and jets travel billions of years before reaching us. When we detect them, we are seeing the echoes of ancient violence, events that happened long before Earth was born. Each glowing ring, each blazing jet, is both a present spectacle and a history book, telling us how black holes shaped the young universe. For astronomers, this violence is a gift. We cannot see inside the horizon, but we can study the neighborhood just outside it. The glowing disks and roaring jets are the messengers, the signals that allow us to infer the hidden. They turn black holes from invisible mysteries into radiant beacons, paradoxically shining brighter than the stars they consume. The violence is not steady, it comes in bursts, in flares, in unpredictable storms. Sometimes black holes sleep, starved of matter, invisible and quiet. Other times they awaken, blazing with power, jets lashing outward. The neighborhood is alive with cycles, feeding and starving, quiet and roaring, a rhythm set by the accidents of cosmic encounters. If one could drift near an accretion disk, the view would be both terrifying and sublime. The sky would blaze with impossible light, photons bent into arcs and spirals by gravity. The roar of radiation would be deafening if it could be heard. Time itself would stretch and warp underfoot. And all around, the glow would circle a hole of perfect black, a silent eye at the heart of the storm. The jets, though born near the horizon, reach far beyond their source. They plow through intergalactic space, heating and stirring vast regions. Sometimes they strike gas clouds, igniting shockwaves that ripple across millions of light-years. The violence of a single black hole can shape the environment of galaxies far beyond its home. In this way, the neighborhood is not local but cosmic, its influence stretching across unimaginable distances. The violence is not just destructive, it can also be creative. The energy from jets can compress gas clouds, triggering new star formation in distant regions. They can sculpt filaments, weave patterns in the cosmos, and even seed magnetic fields across intergalactic space. The neighborhood is fierce, but it is also a forge, shaping matter and energy into new forms. Even as this fury unfolds, the black hole itself remains unchanged. The singularity does not roar, the horizon does not glow. All the violence we see belongs to the matter still outside, caught in the last moments before silence. It is a final performance, a cosmic stage where matter burns with all its might before fading into darkness. The neighborhood is also a puzzle, for we still do not fully understand how jets are launched. Theories suggest magnetic fields twisting in the swirling disk, energy pulled from the spin of the black hole itself. But the details remain elusive, another mystery wrapped in the glow. To study these jets is to peer into the mechanics of the universe's most powerful engines. Some of the brightest objects we know, quasars, are powered by this violence. A single feeding black hole, its disk blazing and jets roaring, can shine brighter than hundreds of billions of stars. Across the early universe, quasars lit the darkness, guiding us with their glow. They remind us that black holes, though silent inside, can blaze as cosmic lighthouses. Yet, even in this chaos, there is rhythm. Matter spirals inward in predictable orbits, light bends along calculable paths, jets follow lines shaped by magnetic fields. The violence is governed by laws, by physics that, though extreme, remain precise. This order hidden within the chaos is part of the beauty of black holes, the way fury and silence intertwine under the same rules. The violent neighborhood is also fleeting. Matter consumed will vanish, jets will quiet, the glow will fade. Black holes can slumber for eons between meals, invisible until new fuel arrives. The fury is not constant but episodic, a heartbeat of light in the long silence of cosmic time. Still, when the fury awakens, it leaves marks that last. Jets carve cavities in galaxies, glowing disks bathe space in radiation, and the structure of the cosmos itself bends under their influence. These scars remind us of the violence long after it fades, fossil records of black holes' roaring feasts. To think of a black hole as silent is true only for its core. Its neighborhood is anything but. It is a realm where gravity orchestrates the brightest light, the fastest speeds, the most powerful outflows. It is a place where creation and destruction blur, where silence breeds fury, where darkness is framed by light. And yet, amid this roar, the horizon remains calm, the singularity unchanged. The neighborhood is theater, but the black hole itself is audience, still, unmoved, absorbing all that comes. The violence is an offering to the silence, a spectacle at the edge of eternity. We call them violent, but they are also breathtaking, their glow a gift across time. Without them, the universe would be dimmer, poorer, less structured. The violent neighborhoods of black holes are not just destructive, they are part of the architecture of creation. They are the loud voices of the quietest hearts in the cosmos. And so, when we speak of glowing disks and roaring jets, we are speaking of the paradox of black holes, the darkest places creating the brightest scenes. Their neighborhoods are violent, yes, but they are also luminous with meaning. They remind us that silence and fury, destruction and creation, are woven together in the fabric of the universe. In the vastness of space, when one drifts too close to a black hole, there is no hand waiting to pull you back. Unlike dangers on Earth, where a friend might catch you if you slip, or a rope might hold you safe, a black hole offers no lifeline. Its gravity is overwhelming, and once you are near its edge, even the fastest signal, the swiftest spacecraft, the most desperate attempt, would not be enough. The rescue would never arrive in time, for time itself bends into the pull, leaving you alone in inevitability. This lonely inevitability is unlike any danger we know. A shipwreck at sea might be saved by a passing boat, a mountain fall might be broken by a rope, even lost wanderers may find their way back. But a black hole is not an accident you recover from. Once its pull takes hold, it is as though the universe itself has written your ending. The inevitability is not cruel in intent, but absolute in law. There is no negotiation, no bargaining, no second chance. Even the idea of a rescue ship traveling near one is filled with futility. The closer it comes, the more its engines must fight against gravity, and yet, no matter how fast it burns, the pull grows stronger. As the victim falls, light itself slows, signals stretch into silence, and to those outside, the struggle fades. No hero can reach across that boundary. It is not cowardice or hesitation, it is the fundamental structure of the universe denying intervention. The loneliness here is deeper than isolation. It is not only that you are alone in space, but that the very possibility of being reached is erased. You could shout, send signals, scream your last pleas across radio waves, but as you near the edge, your cries thin out, red-shifted into whispers that vanish into silence. To the universe beyond, you are already gone, even before you have crossed the line. Rescue does not fail, it ceases to exist. This inevitability is strange to contemplate, for we are used to imagining last-minute escapes, daring rescues, moments where effort might tip fate. Stories we tell are full of saviors who arrive just in time. But here, the story folds differently. Once gravity begins its claim, the ending is written, slow and unstoppable. There is no heroic reversal, only the patient turning of the cosmic page. It is a reminder that not all dangers in the universe bend to human will. For the one falling, the loneliness is not only in knowing no help will come but in how time itself stretches differently. As they fall closer, their seconds elongate compared to those watching from afar. To them, the plunge might seem to take moments, while to others, it stretches into an eternity where their figure slows, freezes, and vanishes. In both frames, there is no hand reaching in, no rope cast out, just the quiet acceptance of the inevitable. Imagine a crew watching a colleague slip too near. They fire engines, shout into comms, and strain their instruments. But to them, the figure hovers, never quite crossing, fading into stretched light. They cannot follow, cannot save, and slowly the truth hardens in their hearts. Their friend is already gone, though their eyes insist otherwise. The loneliness spreads outward, not only to the falling one but to those who must watch, powerless. The inevitability is heavy because it is woven into the very rules of physics. Black holes do not allow half measures. Once the threshold is approached, gravity is absolute. No ship, no beacon, no sacrifice can rewrite the equations. It is not malice, but mathematics, the firm hand of spacetime's structure pulling inward without pause. In this way, the loneliness is cosmic, written into reality itself. Rescue fails because light itself cannot escape. If photons, the swiftest messengers of the universe, cannot climb back out, then no machine or flesh could hope to. To even imagine it is to misunderstand the finality. It is a realm where speed and strength lose meaning, where even hope is slowed, bent, and smothered. The loneliness grows not just from being trapped but from realizing even light will not bear your story outward. This inevitability also strips away pride. Humans often dream of bending nature, of inventing ways to triumph over obstacles, to cheat danger with brilliance. But a black hole allows no such cleverness. It swallows ingenuity as easily as it swallows stars. Its inevitability teaches humility, the sobering knowledge that there are places where no invention, no courage, no devotion can change the ending. It is not a lesson of despair but of perspective. Yet even in this inevitability, there is a strange quiet. The fall does not happen with thunder or violence. Instead, it comes softly, like drifting into a dark sea. There is no explosion, no tearing apart until the final nearness, just the slow pull, the steady drawing inward. It feels almost gentle, even as it writes the end. The loneliness is amplified by that gentleness, the way silence feels louder than noise when no answer comes. Those who fall might, for a moment, believe they could still be saved. Engines flare, hands stretch, signals beam outward. But little by little, the truth becomes clear. The rescue is not late, it is impossible. The lonely inevitability is not cruel because it hides, it is cruel because it is open, obvious, inescapable. You see it approaching, and yet you cannot turn from it. The loneliness deepens because of distance. Black holes are far, scattered across galaxies, separated by oceans of stars. To drift near one is already to be far from home, far from voices, far from familiar skies. To add to that the certainty of no return makes the loneliness almost unbearable. It is not only being trapped but being trapped at the very edge of the universe's silence. In imagining rescue, one realizes how far away it always is. Even light, which takes minutes to cross from the sun to Earth, would take thousands of years. To arrive from many black holes we observe. If you call for help, the message itself will outlast you, reaching others only long after your fall is complete. Rescue, then, is not denied by distance alone, but by time's cruel mismatch, ensuring the call is always too late. The lonely inevitability is also mirrored in the way black holes consume matter. A star shredded into a disk does not reform. Its light bursts forth, but the star itself is gone, pulled in, erased. No companion star can pull it back together. No galaxy can restore it. The inevitability is not only for individuals but for suns, for systems, for cosmic giants. Rescue fails not just for people but for stars themselves. And yet, there is a strange comfort here. The inevitability is not punishment or judgment, it is simply the way gravity works in its most extreme form. There is honesty in that, a kind of fairness. All who cross are treated the same, whether dust or star, signal or ship. In its loneliness, the black hole does not play favorites. It takes all, without anger, without preference, in quiet certainty. This certainty spreads into imagination. If ever a traveler approached, they would know before stepping near that rescue would not come. There is a purity in this clarity, a stripping away of false hope. The loneliness is deep, but it is also free of confusion. One does not wonder what if, because the answer is written into the laws of physics. What is left is simply to drift into acceptance. The inevitability is heightened by how black holes hide behind invisibility. You cannot see them directly. You may not even know you are too close until it is already too late. Rescue cannot come in time because the danger itself is hidden, its true horizon revealed only when it is already closing around you. This invisibility makes the loneliness sharper, it feels like being swallowed by silence itself. Even in thought experiments, when scientists imagine advanced civilizations, no one speaks of saving what has already crossed. The greatest technologies, the wildest dreams, still fall silent at the horizon. The inevitability remains absolute. Even a galaxy-spanning species would only watch as one of their own drifts in, powerless to intervene. The loneliness here is not just personal but universal. For those who remain outside, there is loneliness too. To see a friend fade toward the horizon and know they cannot be touched again is a wound of its own. The inevitability robs not only the one who falls but those who remain. It steals connection, conversation, the possibility of reunion. The loneliness multiplies, spreading outward like ripples, touching more than just the one who vanishes. The inevitability also stretches into time's perspective. To those outside, the fall takes forever, the victim frozen on the edge. Rescue is not only impossible, it is unnecessary, because to the outer eye, the person never seems to cross. Yet both know the truth. The frozen image is not life but a shadow, a stretched echo. Rescue cannot reach shadows. It can only watch them fade. This lonely inevitability is not unique to humans or to imagination. It is written into the way galaxies move, the way stars vanish, the way cosmic history unfolds. Black holes have always been taking, always been waiting, silent and patient. Their inevitability is a thread in the fabric of the cosmos, as constant as starlight, as ancient as creation itself. To sleep with this thought is to lie down with quiet acceptance. Not all stories have rescues. Not all endings can be undone. Some dangers are written in stone, not for cruelty, but for balance, for order. Black holes remind us of that truth. Their lonely inevitability is a part of the universe's design, a reminder of boundaries that cannot be crossed back. The loneliness, then, is not just an ending but a teaching. It tells us that some distances remain uncrossable, that some silences are final. In knowing this, we come closer to humility, to awe, to respect for the vastness that holds us. It is not despair, it is surrender, soft and solemn, to the reality that no quick rescue comes near a black hole. And so, in the lonely inevitability, we glimpse a strange peace. For what is beyond rescue is also beyond fear. What cannot be stopped also cannot be undone. It is a final silence, heavy but honest. In the endless dark, there is acceptance, and in acceptance, a kind of rest. When we think of black holes, our minds often stir with unease, imagining their gravity pulling everything in without escape. But the truth is softer, calmer, and more comforting. Black holes may be terrifying in theory, but they are also distant, far away from our daily lives. The closest known black hole is still thousands of light-years from Earth, so far that even traveling at the speed of light, it would take millennia to reach. This distance is our shield, a quiet comfort reminding us that we are safe from their hungry pull. Their rarity adds to this calm. Though the universe holds billions of stars, only a fraction end as black holes. Most stars live and die without ever collapsing into such extremes. This means that while black holes are real, They are not lurking behind every corner of the night sky. The stars we see above are gentle companions, most destined to fade quietly as white dwarfs or cool into silence, never becoming cosmic abysses. When black holes are imagined as monsters, it is easy to forget that space itself is vast beyond comprehension. Stars are separated by light years, empty gulfs larger than anything we can walk or sail across. A black hole does not roam easily from one system to another. It remains tethered to where it was born, from the core of a star's death or the center of a galaxy. In this stillness lies safety, for the universe's distances are so wide that their reach cannot casually touch us. Astronomers map the skies carefully, and their surveys remind us of this truth. Though black holes are invisible by nature, their presence can be inferred by the way they bend light or influence nearby stars. And yet, even with these sensitive tools, very few have been found close by. Instead, most lie deep within the hearts of galaxies or hidden in the remnants of collapsed stars far beyond our neighborhood. Each discovery is precious because it is rare, not threatening because it is near. The rarity also reflects the balance of the cosmos. For every star that collapses into a black hole, countless others burn more gently, giving warmth and life rather than swallowing it. Our own sun, for instance, does not have the mass to collapse into a black hole. Instead, it will one day swell, shed its outer layers, and leave behind a white dwarf, a quiet ember, not a dark abyss. Knowing this softens our fears, grounding us in the reality that not all stars end in violence. The calm grows when we remember that even the nearest black holes exert no influence here. Their gravity does not reach across the vast emptiness to tug at our oceans or skies. The moon's pull on Earth is millions of times stronger than that of any black hole far away. Their influence is local, confined to the regions close to them. In this way, the universe offers space to breathe, reminding us that distance itself is a form of protection. When viewed through this lens, black holes become less like predators and more like rare landmarks, scattered across the cosmos. Their danger is profound, but it does not extend endlessly. Like volcanoes on Earth, they are fearsome up close but harmless if you live far away. Distance does not erase their power but reframes it, turning terror into quiet or from the safety of observation. This rarity and distance also grant scientists the chance to study without panic. We can peer across light years, analyzing their effects, learning their secrets, while never needing to fear their pull on our world. They are curiosities, puzzles, engines of mystery, but not looming threats. Their remoteness lets us approach them with wonder rather than dread, like children staring at a storm across the sea, fascinated by its power but untouched by its waves. The calm is doubled when we remember the timescales involved. Black holes do not leap suddenly into our skies. Their formation takes millions of years, their influence stretches across epochs, and their motions unfold at cosmic speed, fast to the universe, but unimaginably slow to us. We are safe within these timescales, our human lives too brief to ever witness one sweeping near our system. The very slowness of the cosmos cushions us from harm. Even in galaxies where black holes reign at the center, stars and planets circle at safe distances. The orbits remain steady, as predictable as our Earth's path around the Sun. Gravity, though powerful, also provides order. It binds systems together, keeps them balanced, ensures stability across billions of years. Thus, even the black holes anchoring galaxies are not constant threats but quiet centers around which creation arranges itself. When fears whisper that black holes might someday wander into our sky, it helps to remember that such an event is beyond unlikely. The nearest stars themselves are far apart, and stellar remnants drift slowly. To reach us, a black hole would have to cross unimaginable gulfs, guided by perfect chance. The odds are so slim that they become negligible. The universe is large, and within its immensity, our small corner remains safe. Distance is also a gift in how it allows us to see black holes as teachers rather than destroyers. From afar, their light bending, their jets, their disks of glowing matter become signals for us to decode. They are laboratories written in space-time, observable without risk. Their rarity makes each one precious, their remoteness makes each one safe, and together, these truths transform fear into fascination. Astronomers often speak of them with reverence rather than dread, not because they dismiss the danger, but because they know the distances. They know that the black holes we study are not predators creeping closer but distant beacons showing us how physics stretches to its extremes. Their rareness is what makes their discovery thrilling, their distance is what makes the thrill peaceful. This peace extends into sleep. To imagine black holes while drifting into rest is not to summon nightmares of being pulled away, but to cradle the knowledge that they remain far beyond reach. They are guardians of mystery in far-off skies, not visitors in ours. Their inevitability is softened by their separation, turning their story into a lullaby of perspective, not a warning of danger. The calm is also found in scale. A single black hole, no matter how immense, is still a dot compared to the immensity of a galaxy. Our Milky Way, with its hundreds of billions of stars, holds only a scattering of them. To dwell on the rare few is to miss the vast gentle sea of starlight that surrounds us. This ratio itself is comforting. The universe leans toward abundance of light rather than scarcity. Even the thought of supermassive black holes does not need to stir dread. They sit quietly at the hearts of galaxies, their orbits stable, their influence extending in balance rather than chaos. They are anchors, not wanderers, and their rarity means only the grandest galaxies host them. Our galaxy's own supermassive black hole, Sagittarius A, has existed for eons without threatening Earth. Its distance is vast, and its calm presence has been part of our history since long before we looked to the sky. Distance and rarity also remind us that fear itself is often an illusion born of misunderstanding. To imagine black holes as devourers without limits is to forget the emptiness of space, the immense stretches that separate them from us. To know their true nature is to see them more clearly. Yes, they are powerful, but they are not close, not numerous, not waiting at our doorstep. Knowledge replaces dread with serenity. There is comfort, too, in knowing that black holes are not predators actively hunting. They do not move through the universe seeking prey. They are where they are, the remnants of stars, the hearts of galaxies. Their hunger is passive, their gravity unchanging. To fear them as monsters is to project human imagination onto cosmic order. In truth, they simply are, rare and distant, and that quiet fact is calming. Even when stories imagine a rogue black hole wandering near. Such tales are more fantasy than fact. The physics of the cosmos make such encounters nearly impossible, like two grains of sand drifting toward each other across the expanse of a desert. The rarity is not only statistical but structural. The cosmos has arranged itself in a way that protects us from frequent meetings with such extremes. Distance also grants us perspective on our fragility. It allows us to admire from afar without harm, to recognize power without succumbing to it. Just as we watch storms from the safety of shore, we watch black holes from the safety of light years. This awareness brings humility but also comfort, a reminder that danger is part of the universe but does not always dwell near us. When we look at the night sky, the calm is reflected back. The stars we see are mostly ordinary, steady, safe. The rare black holes hidden among them do not change the beauty overhead. Their rarity allows us to marvel at starlight without fearing every twinkle hides an abyss. The vastness of distance lets us gaze upward with peace, knowing the danger is far removed from the gentle constellations. The calm grows stronger the more we learn. Knowledge turns shadows into shapes, fears into facts. By mapping the skies, astronomers show us that black holes are not unknown terrors hiding nearby but distant phenomena with names, positions, and predictable behaviors. They transform the abyss into a charted presence, and in charting it, they give us calm. This distance and rarity do not lessen the grandeur of black holes, they heighten it. They allow us to look upon them with awe, to treat them as wonders of physics rather than threats to life. Their very remoteness makes them more mysterious, more special, jewels scattered sparsely in the deep dark. Each one is a rare gift for our telescopes, not a shadow over our sleep. To carry this calm into thought is to remember that not every cosmic truth is a danger to us. Some truths are lessons, distant reminders of how vast and varied the universe is. Black holes are one of those truths. Their presence is undeniable, their power unimaginable, but their distance and rarity keep them from our doorstep. They are stories of elsewhere, not of here. And so, when fear stirs at the thought of them, let distance soothe you. When imagination conjures their hunger, let rarity calm you. They are not waiting in our sky. They are far away, few in number, and bound to their places. The universe has scattered them widely, not crowded them close. In this scattering lies our peace. To know this is to find stillness. Black holes remain, but they remain far. Their danger is not ours, their rarity is our safety. The night sky can be gazed upon without fear, each star a companion, each dark space a cradle of mystery rather than menace. Distance and rarity are not just facts, they are reasons for calm, soft blankets laid over the mind as it drifts toward rest. And so, as you breathe deeply and let the night hold you, remember, the black holes that seem so frightening are far away, few in number, and fixed in their places. They will not come for you, and they cannot reach you. What remains for us is not fear, but wonder, a gentle calm at the thought of mysteries that live far beyond our world. Black holes scare us because they symbolize endings that cannot be undone. Unlike most dangers we know, they do not leave room for recovery, no escape, no second chance. Their gravity is absolute, their silence unbroken, their inevitability terrifying in its honesty. They remind us of mortality in a cosmic mirror, that there are limits beyond which no one can return. Yet, in that very truth lies a kind of comfort, for their inevitability is not malice but law, not cruelty but nature's steady hand. They frighten us because they are invisible, their presence betrayed only by the bending of light or the violence of nearby matter. We fear what we cannot see, and black holes are the purest expression of that fear. An invisible predator, silent and patient, waiting in the dark. Yet even here is comfort, because their invisibility is not a trick, they are where they are, fixed, not creeping toward us. The unseen is scary, but knowing its boundaries turns the fear into calm. Their power unsettles us. The thought of something that can swallow stars, consume light, and distort time itself is overwhelming. Our minds recoil at forces so much larger than ourselves. But the comfort comes from remembering scale. Black holes are rare, scattered, and distant. Their power is vast, but it does not reach across the cosmos to us. The universe is large enough to hold them without letting them dominate everything. Their power is real, but their reach is not near. We fear them because they bend the laws we rely on. Time slows near them, space warps, light curves. The familiar rules of distance and duration dissolve, and we lose our footing. The unknown frightens us most when it touches the fundamental fabric of reality. Yet in this strangeness lies wonder. They do not erase physics, they expand it, teaching us more about the universe than any ordinary star could. The fear is balanced by awe, the terror softened by knowledge. The very name, black hole, feels ominous. It suggests an absence, a void, a pit without end. Language feeds our imaginations, painting them as abysses waiting to swallow. But words, too, can be softened. They are not holes torn into existence, but the final forms of stars, born from natural cycles, cradled in the same laws that shaped galaxies. To reframe the name is to turn fear into poetry, to see them as endings that are part of the greater story. They scare us because they are silent. Unlike storms or earthquakes, they do not roar or crack. They pull without sound, and silence often feels more dreadful than noise. Yet silence can also be soothing, a hush rather than a scream. In the quiet of a black hole, there is no malice, no intent, just the stillness of gravity at its deepest. To fear silence is natural, but to rest in it is peaceful. Black holes embody both truths. The idea of being stretched, spaghettified by their pull, chills the imagination. Our bodies, fragile against such forces, remind us of our smallness. Yet spaghettification, as strange as it sounds, is not a punishment but a result of simple physics. It happens only when one ventures too near. From far away, there is no such tearing, no danger at all. Fear imagines that we are already at their edge, but comfort whispers, we are not. We fear them because they trap even light, the swiftest thing we know. If light itself cannot escape, then nothing else could either. This finality stirs dread, for we like to imagine that anything might always slip away. But the comfort is that light does escape in a different way, not from within but from around. The glowing disks, the blazing jets, The warped halos all reach us, carrying stories across galaxies. Even near black holes, light finds a path. The fear is sharpened by their mystery. For centuries, black holes were only equations, invisible predictions, whispers of possibility. That they turned out to be real makes them feel more uncanny, as if the universe hides secrets too vast for us to know. But mystery itself is not danger, it is invitation. The unknown can frighten, but it also sparks wonder, a reason to keep looking, keep learning. Black holes are mysteries, but they are not threats to our lives here. They also scare us. Because they defy imagination. To picture a singularity, an infinite point where physics breaks, is to confront the limits of our understanding. We are not used to facing infinities. They seem alien, impossible. Yet comfort lies in remembering that these infinities are questions, not answers. We do not know the final truth of singularities. That ignorance frightens us, but it also means possibility, room for discovery, room for hope. The fear comes, too, from scale. A supermassive black hole millions or billions of times the sun's mass sounds like a monster beyond comprehension. How could such a thing exist, we wonder, without consuming everything? Yet here lies calm. Those giants are stable, their galaxies balanced around them for eons. They are anchors, not predators. They hold the dance of stars together, their enormity a source of order, not chaos. We fear their finality, for they symbolize endings we cannot resist. Once you cross the horizon, there is no return. This absolute one-way passage mirrors death itself, and so black holes become metaphors for our own mortality. That thought chills us. But there is comfort, too, in knowing that endings are part of the cycle, that stars themselves give their lives to form these objects. In their finality, they reflect the truth of all life, that endings make space for beginnings. Their unpredictability frightens us, too. Stars can wander close, gas clouds can ignite, sudden flares can blaze across galaxies. Black holes seem like sleeping beasts that can wake without warning. Yet their unpredictability is not directed at us, it unfolds in distant corners of the cosmos, far beyond our reach. To us, they are steady, unmoving, their slumbers and awakenings visible only in telescopes. We watch, but we are not touched. The fear deepens when we imagine falling into one ourselves. To picture drifting toward the horizon is to picture helplessness. But the comfort here is found in perspective. None of us are near such a fall. The Earth is safe in its orbit, our Sun is safe in its lifetime, our system is far from any such abyss. The scenario that frightens us is one we will never face. It is a thought experiment, not a future. They frighten us because they exist at the edge of knowledge. Science itself admits, here, our maps end. At the singularity, we do not yet know what happens. This admission feels like standing at the edge of a cliff in the dark. But there is comfort in honesty. To confess ignorance is not weakness but courage. It opens doors for future discovery. Black holes are not walls, they are thresholds, inviting us to explore. The idea of nothing escaping frightens us because it contradicts our instincts. We like to believe there is always a way back, a way out. A black hole says no. Its horizon is absolute. This frightens us with its clarity. Yet comfort lies in that same clarity. There is no deception, no hidden rule. The boundary is sharp and true. To cross it is to know, without doubt, where you are. There is fear in absolutes, but also peace. The fear is magnified by art and story. We imagine them as monsters, as devourers, as dark mouths swallowing the universe. Our own creativity amplifies their menace. Yet in truth, they are not hunters. They are not alive. They do not chase, do not hunger with intent. They simply are. The comfort comes when we strip away the stories and see them clearly, not monsters, just natural phenomena, rare and distant. We fear them because they are permanent. A black hole does not fade in moments, it lasts for billions upon billions of years. That endurance makes it seem unstoppable, eternal. But permanence can also be comforting. It means stability, constancy. It means they are not chaos but fixtures in the cosmos, reliable presences that follow predictable laws. Their permanence, frightening at first, becomes reassuring. The fear extends to their hunger, the thought of them swallowing stars whole. Such destruction seems violent. But the comfort is in scale again. Stars live billions of years before they are ever threatened. Planets circle in safety far from their reach. Black holes do not consume without cause, they feed when something strays too near. To live far is to live untouched. In a universe so vast, most things will never come near enough. Their unpredictability also frightens us in the way they flare with X-rays, erupting suddenly as matter falls in. But these flares, frightening in imagination, are simply signals for us, signs we can study. They are not reaching across the cosmos to scorch us. They are distant fireworks, dangerous only to those already at their edges. To us, they are stories of physics, not threats of doom. We fear them because they remind us of emptiness. They are voids, places where something once was and is now gone. Emptiness makes us uneasy, it suggests loss, absence, silence. Yet emptiness can also be a kind of canvas. Black holes mark places where stars ended, but their presence allows galaxies to form, stars to orbit, light to bend. In their emptiness, they create structure. In their silence, they give shape to the cosmos. The fear comes from imagining them as endings. But comfort comes when we remember they are also beginnings. Jets from black holes stir galaxies, trigger new star formation, seed magnetic fields across the universe. Their violence is creative as much as it is destructive. They do not only take, they give, shaping the cosmos we inhabit. In their dark centers, they hold the light of future generations of stars. They frighten us because they are alien, unlike anything we experience daily. We can understand rivers, storms, fire. But a place where time slows, where escape is impossible, feels foreign. Yet alien does not mean hostile. They are different, yes, but not against us. The comfort lies in seeing them as part of the tapestry of existence, unique threads woven beside the familiar. Difference need not mean danger. Their scale also frightens us in another way, how small they make us feel. To know such giants exist makes our lives seem fragile. But smallness can be comforting, too. It reminds us that our worries are not the whole universe, that our struggles are tiny compared to cosmic time. Black holes give perspective. Yes, we are small, but we are also here, alive, safe, able to look upward in wonder. We fear them because they symbolize limits. They are the edge of what we know, the end of what we can resist. Humans do not like limits, we prefer freedom. But limits can comfort too. They tell us where not to go, they create boundaries within which life flourishes. Black holes are not obstacles in our daily path, they are distant borders, far outside the region where we dwell. Their limits shape the cosmos, but not our lives. Even the thought of falling in frightens us less when we remember distance. Black holes are scattered sparsely across galaxies, hidden in remote corners. The nearest is far beyond reach. Their rarity and separation are shields. We can imagine the fall, but we will never feel it. Fear imagines closeness, but comfort insists on truth. They are far away, and we are safe. The deepest fear is that black holes are unknowable. We like answers, closure, certainty. A singularity seems to deny us those. But comfort comes in seeing them as mysteries left for future generations, puzzles not yet solved but waiting. The unknown is frightening, but it is also hopeful. Black holes remind us there is always more to learn, more to seek, more to discover. And so, the poetic truth of why they scare us lies in what they represent: endings, silence, absence, power, infinity. They mirror our deepest fears, the ones beyond survival, the ones about mortality, meaning, and the unknown. But in every one of those fears lies a comfort. Their distance protects us, their rarity reassures us, their balance anchors galaxies, their mysteries inspire us. They are not just monsters in the dark. They are teachers, reminders, and symbols of the universe's depth.